So the next question is, second question A part, explain the architecture of a typical embedded device based in ARM core with a neat diagram. It is asked for 8 marks from Jan February 2021. Okay. So the architecture of embedded device based in ARM. So this diagram gives you the ARM based embedded device, that is a microcontroller. Okay. So this altogether will be your microcontroller structure. Okay, it mainly consists of four important hardware components. So what are the four important components? That is, one is your ARM processors, controllers, peripherals, and your bus. Okay, so each blocks, here you have each blocks will or your each box will represent a feature or a function, and these lines represents the bus. Okay, lines connecting the boxes are the bus carrying the data. Okay, so first let us see the important points of these four hardware components. Okay, so the important points which you can write here is, what is an ARM processor? Four different hardware components, right? ARM processor, controller, peripherals, and bus. Okay, so what ARM processor, the first point is it controls the embedded device. Different versions of ARM processors are available. So what and all it comprises? It includes a core and the surrounding components. Okay, that is what written. It comprises a core plus the surrounding components that interface it with a bus. Okay, through the bus the different components will be connected. So what are these surrounding components? Mainly it is a memory management devices and your cache. Okay, now the next one is your controllers. What does the controller does? It coordinates the important functional blocks of the system. There are two common controllers. What are the two common controllers? One is your interrupt controller and the second one is your memory controller. Whereas in the case of peripherals, means you know that the different input and output devices, right? It provides all input and output capability external to the chip, that is off chip. Okay, and it is responsible for the uniqueness of the embedded device. And the last but not the least, you have the bus. So what is the use of bus? It is used to communicate between the different parts of the device. Okay, so these are in general the four different hardware components and its important points. Now you are going to elaborately study about your 4 different topics. First one is your ARM bus technology, and then you have AMBA bus protocol. Then you have memory. Under the memory, you are going to study the different characteristics of the memory. One is hierarchy, width, and the types. And the last one is your last topic is going to be your peripherals. Under peripherals, you are going to study the two specialized peripherals, which is the controllers, that is your memory controller and interrupt controller. So in detail, you have to write these points for these different topics. Okay, so first one is your ARM bus technology. So embedded devices uses an on-chip bus inside the chip, right? That is internal to the chip and that allows different peripheral devices to be interconnected with an ARM core. Okay, there are two different classes of devices attached to the bus. So what are the two different main classes attached? One is your master and the other is your slave. So it is called as bus master and the bus slave. What will be your bus master? It is nothing but your ARM processor core. And what will be your slaves? It is bus slaves is going to be your peripherals or the input output devices connected. So the ARM bus master are the logic device capable of initiating the data transfer with another devices across the same bus. Usually it is the ARM processor core. Whereas in the case of what does your bus slaves does? It is a logical device capable only of responding to the transfer request from a bus master device. Okay. There are two architecture levels. One is your physical level and the other one is your protocol. So what is meant by physical level? It covers the electrical characteristics of bus width 16, 32 or 64 bits. Whereas protocols means the logical rules that govern the communication between the processor and a peripheral. Okay, and the next one is going to be your next topic. First topic is done. Now second important topic here, AMBA bus protocol. So AMBA stands for Advanced Microcontroller Bus Architecture. It was introduced in 1996. Okay, so the first AMBA technology was your ARM bus system, which is given as ASB, and ARM peripheral bus, that is APB. Later, what was developed? AHB, that is for high performance, ARM high performance bus was developed. Okay. what is the specialty of this? It can connect large number of peripherals. Okay, large number of peripherals can be connected. That is, hardware designers have a wide choice of tested and proven peripherals for use in the device. So the specialty of this is the peripheral can simply be bolted onto the chip bus without having to redesign an interface for each different processor architecture. So this plug and play interface for hardware developers improves the availability and time to the market. Okay. So this AHB, that is your ARM high performance bus, has high data throughput than your ASB. Okay, that is your ARM system bus. So why? What is the reason? Because AHB uses the centralized multiplexed bus scheme, whereas your ASB, that is your ARM system bus, uses bidirectional bus design. So the next point is AHB bus runs at higher clock speeds and supports widths of about 64 and 128 bits. Okay. Now your ARM has two variations of AHB bus. So this AHB bus can be again classified into multi-layer AHB and AHB Lite. So multi-layer AHB means it allows multiple active bus master, whereas here it is limited to a single bus master. It is a subset of AHB bus and is limited to a single bus master, that is AHB Lite. Okay. Now this AHB and the multi-layer AHB means your major type, that is your ARM high performance bus. Okay. And your multi-layer AHB supports same protocol for master and slave but have different interconnects. So what these new interconnects are good for systems with multiple processor. Operations occur in parallel and allow for higher throughput rates. Okay. So in the figure, what you have 1 to 3 different types of buses. One is your AHB bus, that is your AHB bus, and your APB bus and your external bus. Three different. APB means peripheral. This is to the core, connected to the core. External to the external devices. That is what given. Okay. So in the figure you have three different types of bus, that is AHB. So the next topic is going to be your memory. Under memory you are going to study three different characteristics, right? One is your hierarchy, width and type. So this is your diagram which gives you the memory trade-offs, that is memory size versus your performance and cost. Okay. So in this the fastest memory cache is physically located nearer to the ARM processor core, and the slowest secondary memory is set further away. Okay. Closer memory is to the processor core, the more it costs and the smaller its capacity, right? So here cache is smaller in capacity. Now you will be seeing about your cache, main memory and your secondary storage. Cache is placed between the main memory and the core. It speeds the data transfer between the processor and the main memory. Okay, what about your main memory? So the main memory is large, around 256 KB and 256 MB, or even large depending on the particular application. It is generally stored in a separate chip. Okay, secondary storage, it is largest and slowest form of memory. Example are your hard disk drives and CD-ROM drives. It is size is about 600 MB to 60 GB. The next is your second characteristics is your width. So what is meant by width? It is the number of bits the memory returns on each access. Typically it can be 8, 16, 32 or 64 bits. Okay. It has a direct effect on the overall performance and the cost ratio. For example, this gives you the table which gives you the elaboration of your fetching instructions from a memory. So here you have two different instructions used. One is your ARM 32-bit and thumb 16-bit. Okay. So in the first, let us take the first case. If the core is using ARM 32-bit instruction and a 16-bit memory chip, then the processor will take two memory fetches, right? Two cycles, two memory fetches per instruction. Each fetch requires two 16-bit loads. So it reduces the system performance. The benefit is that the 16-bit memory is less expensive. Whereas in the case, if you take the second case, it is using, the core is using thumb 16-bit instruction, and 16-bit memory means it gives better performance with 16-bit memory. Why? The reason is that it uses only a single fetch to load an instruction. It gives improved performance and reduced cost. Okay. And the last type of characteristic is your type. So you are going to study 1, 2, 3, 4, 5 different types. One is your ROM, second one is your flash ROM, third one is going to be your DRAM, fourth one SRAM, and the fifth one is going to be your SDRAM. So ROM, you know that it is read-only memory. So it is least flexible because it contains an image that is permanently set at the production time and cannot be reprogrammed. So it is used in high volume devices that require no updates or correction. Second one is your flash ROM. Flash ROM is nothing but it is a hybrid, okay? Both read and write, okay? Both RAM and ROM functions. So it can be written as well as read. It is slow to write, therefore cannot be used for holding dynamic data. The main use is for holding device firmware or long-term data that needs to be preserved after the power is off. So erasing and the writing is both is software controlled, okay, with no additional hardware. So that's why you have the manufacturing cost to be very, very less. It is used, sometimes it is used as an alternative for mass or secondary storage. The third type is dynamic random access memory or your DRAM. So DRAM, it is the commonly used random access memory. It is it has the lowest cost, and your DRAM is dynamic. Why? What is the reason? It needs to have its storage cells refreshed and given a new electronic charge every few milliseconds. So DRAM controller must be set up before using the memory. So the next type is going to be your static random access memory or your SRAM. So it is faster than the DRAM, but more it takes more silicon area. The SRAM is static in the sense the SRAM does not require refreshing. Now the access time of your SRAM is always less than that of the access time of your DRAM. Because of the higher cost, it is used mostly for smaller high-speed tasks such as fast memory cache. Okay, SDRAM. So SDRAM stands for synchronous dynamic random access memory. It is one of the subcategory of your DRAM. It can run at higher clock speeds than conventional memory. It synchronizes itself with the processor bus. Why? Because it is clocked. Internally, the data is fetched from the memory cells. It is pipelined and given onto the bus in the form of burst. Okay. And the last one is called as your peripherals. So a peripheral device performs the input and output functions for the chip by connecting to other devices or sensors that are off chip, external. Okay. So each peripheral performs single functions and reside on chip. All ARM peripherals are memory mapped. One of the specialized peripherals are your controllers. There are two types. One is your memory controller and your interrupt controller. So under memory controller, it connects different types of memory to the processor bus. On the power up, a memory controller is configured in hardware to allow certain memory devices to be active. These memory devices allow the initialization code to be executed. Some memory devices must be set up by the software. Okay, when using DRAM, the memory timings and the refresh rate has to be set up before it can be accessed. Whereas what is your interrupt controller? Name itself gives you the meaning. When a peripheral or a device requires attention, it raises an interrupt to the processor. It provides a programmable governing policy that allows the software to determine which peripheral or device can interrupt the processor at any specific time by setting the appropriate bits in the interrupt controller register. There are two types of interrupt controller. Okay. So yeah, it is first one is called as your standard interrupt controller, and the second one is called as vector interrupt controller, or it is called as VIC. So standard interrupt controller, it sends an interrupt signal to the processor core when an external device requests servicing. It can be programmed to ignore or mask an individual device or set of devices. The interrupt handler determines which device requires servicing by reading a device bitmap register in the interrupt controller. Whereas in the case of vector interrupt controller, what is happening? You have priority. Okay, more powerful because it is it prioritizes the interrupts and simplifies the determination of which device caused the interrupt. So in this case, if the priority of the new interrupt is greater than the currently executing interrupt, then depending on this condition, it will have two options. Okay. Either it will call standard interrupt execution handler, which can load the address of the handler for the device from the VIC, or it causes the core to jump to the handler for the device directly. These are the important points which you can write for the question. Explain the architecture of a typical embedded device based in ARM core with a neat diagram, which is asked for 8 marks.